Yes, so welcome to our classroom. Here we are going to discuss about the force between two parallel current carrying conductors. The force between two parallel current carrying conductors. So, as we know the basic concept, if any current carrying conductor that produces magnetic field which is exactly perpendicular to the current direction. Okay, and we have studied Bell-Savart law and Ampere circuit law. Yes, so from that one we are going to apply here. Okay, the concept is here. We have two wires. Those two wires are parallel to each other. The first case, in the two parallel wires, the current is passing the same directions. In the second case, the current is passing in opposite direction in that both wires. So one wire goes in the upward direction and the other wire the current will go in the downward direction. That is the second case. And here we are going to discussing about force between these two wires. So as we know that Fleming's left hand rule, right? If you are providing current and magnetic field, obviously there is a force is exerted between exactly perpendicular to current and magnetic field. Yes, and here I have chosen two different wires. Both are simultaneously equal in length, diameter and resistivity, everything is same. But I have chosen two different wires. So wire 1 and this is wire 2. Okay, in that wire 1 the current is passing in upward directions. And similarly in the wire 2 the current is also passing in the upward direction. Current passing in the first wire is I1. In the second wire is current passing is I2, right? Now, what we are going to discuss here. So, due to this current, okay, is flowing in that first wire. Yes, what happened? It produces some magnetic field, right? That magnetic field is, listen here, we have the second wire here, yes? And that wire, second wire, that magnetic field is exactly perpendicular to this wire, right? Yes, okay. So if current and magnetic field is developed, providing current, magnetic field is developed. So the current and magnetic field is developed in the sense, what will happen? The force will be created. That force will be acted towards the wire 1 because apply Fleming's left hand rule. Okay. So here we have the current direction which is in middle finger and the force will be exactly in that directions and the magnetic field will be in this direction. Always is projected outwards. Okay, projecting outwards. But remember that this magnetic field is into the paper. Why we are saying into the paper? Look at the diagram. In that diagram, the magnetic field lines are revolving in anti-clockwise direction. That's why we are saying that into the paper, right? Can you? Okay. And similarly, this wire will exert some force on this wire. That's why we wrote on F2, right? And this wire also exerts some force on this wire. That is here F1. Yes. Remember, due to this current carrying conductor, it exerts some force in that second wire that we are saying as F2. Magnetic field is B1 and similarly here the magnetic field is B2, right? It's clear? Yes? Okay. Now I am doing some small demo for you. So this is a straight line conductor. I cannot hold two parallel conductors right now because I have only two hands, right? Okay. So this metal scale is a straight conductor and here the magnetic field is this wooden circle. Okay. So here the magnetic field is produced, right? So look at here the picture. So where the magnetic field which is exactly perpendicular to this wire 2, right? Yes? Okay. So now what you are going to do? This is current direction, right? And the magnetic field is here. So this is one direction, this is another one direction, 90 degree. Both are perpendicular to each other. Then the force will be exerted on this system, right? This wire, that is F2, that is acting towards the wire 1. So using Fleming left hand rule here, right? And coming back to here, this is for the force is produced due to wire 1, and here the force is due to wire 2, right? So the wire 2 having the current is I2, and the magnetic field is here also, it is into that plane of paper, right? Because the magnetic field lines are revolving in the anti-clockwise direction, right? But look at here, the direction of magnetic field here I noted out as like that. Yes, because here it cannot goes like this way, because it's rotating in anti-clockwise direction. The projection, that is main, right? It's taking away from it, right? Okay. And we know that the force on a current carrying conductor F is equal to BIL sin theta, right? So here I have chosen the force F1, sorry, here I need to write F2, not F1, F2, these are all F2. So this is, we can write B2, F2, F2. Okay. Okay. Yes. Here this is B1 only. No problem. Okay. So F2, that is a force is exerted on the wire 2 by wire 1. That is F2 is equal to B1I L sin theta. So what is the I here? Yes. That is I2 here. That current in the wire I2 is, current in the second wire is I2. Therefore, I can write I2. And from Ampere's circuit law, B1 is equal to mu naught I1, right? So mu naught I1 divided by 2 pi r. Substitute this B1 here. So mu naught I1 I2 into L divided by 2 pi r. So F2 divided by L is equal to mu naught I1 I2 divided by 2 pi r. Similarly, if you are calculating for the force on F1, right? The force by calculating the force F1 due to the wire 2 on the wire 1. So that case the same thing will be happen. So again I am telling, look at the picture. Here the force is acting inwards towards the current wire 1, and here the force is acting towards wire 2. So both the forces are equal and opposite. Why I am saying equal? Because these two has given us same value, right? But the direction, if you look at it will be in opposite direction. Therefore, the concept is here, if you are passing a current in parallel current carrying conductor in the same direction, it attract each other. So the current are parallel which attract each other, right, in same directions. If you are passing in same direction, you are passing the same current in the direction, that will be attract. And similarly for anti-parallel, okay, so anti-parallel it will be ripple. So here also the force will be the same, but the forces are ripple to each other. So whenever if you are having like this type of one second, I will show. Yes, when the current are passing in parallel direction, these two current exert the force and get attracted to each other, okay. But in the case of anti-parallel, the currents are moving in opposite direction. This one for upward direction, this one is downward direction. Since these two carrying conductor will exert the force in the repulsive force, it get separated, right? So this is a very good example for understanding this concept in this topic, right? I hope you enjoyed and understood the concept. Thank you. See you in next video.